So, good day. I am going to discuss about the information capacity. So, first, what is the information theory? Information theory, this is a highly theoretical study of the efficient use of bandwidth to propagate information through electronic communication system. So, this studies the transmission, processing, extraction, and utilization of information. Another is that information theory can be used to determine the information capacity of a communication system. Next is the information capacity. Information capacity, this is a measure of how much information can be transferred through a communications system in a given period of time. So information capacity also represents the number of independent symbols that can be carried through a system in a given unit of time. So the amount of information that can be propagated through a transmission system is a function of system bandwidth and a transmission time. So Claude Shannon, he is an American mathematician born on April 30, 1916. He is the founder of information theory. So in 1948, Claude Shannon, who also took a position in Bell Telephone Laboratories, published a paper in the Bell System Technical Journal entitled A Mathematical Theory of Communication, which relates information capacity of a communication channel in bits per second to bandwidth and signal-to-noise ratio. So, mathematically stated, the Shannon limit for information is this. So, the formula for the Shannon limit for information capacity. So, this has a formula of C equals to B log base 2 times 1 plus signal to noise ratio, wherein the C is the maximum achievable data rate, which has a unit of bits per second. Next is the B, which is the bandwidth, and the unit is hertz. Next is the signal to noise ratio, and the S there is the signal power and has a unit of watts. So if ever the given signal is in decibel, it should be converted to watts. So as you can see, here is how to convert the decibel to watts. So example, if you have 10 decibels as a given, you have to convert it to watts. So 10 raised to 1 and so on. So here are the sample problems for information capacity. So first one is, consider that a 200 kbps data stream is to be transmitted on a voice grid telephone circuit with a bandwidth of 6 kHz and has a signal to noise ratio of 20 decibel. What is the information capacity? So the given into this problem is the bandwidth is equals to 6 kHz. So the signal to noise ratio is equals to 20 decibel and being converted to watts, which now has a value of 100 watts, since 10 raised to 2 is 100, and it was discussed earlier how to convert the signal to noise ratio. So here is the formula, and to get the answer, simply substitute the given to the given formula, and as you can see, we would get an answer of 39,949.2689 bits per second, and to be converted to 39.95 kbps. So next problem is, a telephone has a bandwidth of 2 MHz. So calculate the information capacity with signal to noise ratio of 30 decibel. So in this problem, this is similar to the first one and has a given of bandwidth, which is 2 MHz, and signal to noise ratio of 30 decibels. So again, convert it to watts, just like what was done earlier. This would be 10 raised to 3. This is a direct substitution. Here is the formula, and simply input it to the calculator and we would get an answer of 19,934,400 452.52 bits per second and convert it, and we would get an answer of 19.93 Mbps. Third example is there's a microphone signal that has a bandwidth of 7 MHz and has a signal-to-noise ratio of 50 decibel. Calculate the maximum data rate of the channel. So there are bandwidth of 7 MHz and a signal-to-noise ratio as a given. Signal-to-noise ratio is the 40 decibel, and the signal-to-noise ratio is converted to watts and now has a value of 10,000 watts. So the given values would be directly substitute to the formula, and the answer would be 93,014,996.49 bits per second. And convert it, and we would get an answer of 93.01 Mbps. The last example is a standard TV channel line with a signal-to-noise ratio of 20 decibel. What is the required bandwidth to attain the maximum data rate of 5 kbps? In this last problem, the unknown is the bandwidth, which means that the main formula would be derived, and as you can see, so the formula was being derived to compute for the bandwidth, and the given is the maximum data rate, which is equal to 5 kbps, and the signal to noise ratio is 20 decibel. And when the formula was derived, simply substitute the given, and we would get an answer of 750.95 hertz, and that will also be converted to kilohertz and would have a new value of 0.75 kilohertz. So that's all for the information capacity. Thank you.